Hello, I'm a presenter of Team6. Let's start the presentation. Before starting our presentation, let me introduce our final presentation contents briefly. First, we focused on architect's design purpose. And then we addressed the three major design properties and challenges arising from these properties. Let's begin our main contents with a short video.
I remember one day we got an email, but when I opened, I saw congratulations. Mississauga has ambition to build a future. So I think the question is, what's the future city look like? In the high-density urban context, we should introduce nature. So I was quite sure our tower shouldn't be another memorial or symbol for the strength or power. We should introduce this beautiful curve, the softness. The opportunity was rare, not only for me, but also for a city like Mississauga.
Yan Song-ma is both founder and chief architect of MAD Studio. He designs naturalistic architectures to make harmony of the environment and architecture. Throughout the process of urbanization, the concrete groups only focused on the efficiency of space. Feeling skeptical about these problems, Yan Song-ma questioned how to create residents where humans can feel the richness of nature as much as possible in urbanization. After much of thinking, Yan Song-ma designed the Absolute World Tower. Absolute World Tower's design reflects Yan Song-ma's design spirit. The building contains three characteristics opposite to common skyscrapers, and they are naturalism, delicacy, and humanity. Absolute Tower has three major design properties: rotating slab, cantilever structure of balcony, and high-rise building. Let's deal with the challenges arising from these properties. The most conspicuous characteristic of the Absolute World Tower is a rotating slab. Also, the important feature is that it has a flat plate structure. It is a type of architectural structure consisting of columns and slabs without beams, which are horizontal structural members connected to columns of vertical materials and supporting loads. The two major features, a rotating slab and the flat plate structure, cause two problems. The first problem is structural instability. This can be figured out by three methods. Let's begin with the load-bearing wall. These are two different floors of the Absolute World Towers respectively. Although the rotation degree between the two slabs are very different, the load-bearing wall is located at the same position on each floor. Also, the load-bearing walls extend or contract according to the slab. Different from the column structure, the load-bearing wall supports each slab with sustaining accurate consistency. Therefore, the load-bearing wall contributed to supplement the structural instability of the Absolute World Towers. The second method is use of self-consolidating concrete. The rotating slab of the absolute world towers requires a high-performance concrete. To operate as a high-performance concrete, high strength, high flow, and high durability are needed. Generally, when the concrete strength increases, the concrete flowability decreases according to the increase of the concrete strength. However, in the case of self-consolidating concrete, it can raise the flowability of the concrete while maintaining sufficient strength to withstand the vertical load. The last method used to solve the problem is a post-tensioning method. In the case of the pre-stressed concrete, pre-tensioning and post-tensioning method can be used. Among these two methods, absolute world towers use the post-tensioning method. In post-tensioning method, the shed tube with the strand is placed in the formwork after concrete pouring hardening. With applying tension, we add the stress to the concrete. Therefore, using post-tensioning method, we can conclude that the intensity of the concrete increases. Among the two problems, the second problem is the difficulty of construction. This problem takes place because of the two conspicuous features of the absolute world towers, the elliptic slab and the rotating slab. The difficulty of construction caused by the elliptic slab is solved through skydeck, and that of the rotating slab is figured out by RCS form. Let's begin with the skydeck. The picture on the left side is the elliptical slab of the absolute world towers. Due to the elliptical shape, the panel cannot be cut in an identical shape. Engineers assembled the standardized rectangular panels and filled the rest with specially produced panels to match the shape. The difficulty of construction caused by the rotating slab is figured out by the RCS form. RCS form is the rail climbing system. The most important reason why RCS form is used is that it can be stacked exactly at the right angle. Therefore, the absolute world tower with different angles of slabs rotating on each layer was also able to implement the correct angle using RCS form.
The figure represents one floor of the absolute tower. The absolute tower has a structure in which the balcony wraps around the entire building. There are horizontal and vertical flow of heat. How does the thermal break specifically control the flow of horizontal heat? In case of the absolute world towers, the balcony encloses the whole floor, so the balcony is exposed to outdoor. Thus, the balcony is directly affected by the climate. If the temperature of an external balcony slab decreases due to the outside temperature decrease, The internal floor slab also decreases, resulting in heat loss. It is a summer break that can deal with these problems. Summer break is a structure in which a reinforcement that connects the external balcony slab and the internal floor slab crosses the summer insulation in the middle. There is an external balcony slab and also the internal floor slab. Between the external balcony slab and the internal floor slab, the horizontal heat transfer occurs. The method that prevents the horizontal heat transfer is summer break. Thus, we can notice that the horizontal flow of heat can be adjusted by the summer break. Let's move on to the solution of vertical heat transfer, bulkhead, the summer insulator. Bulkhead is used to prevent vertical heat transfer. In the case of protruded balconies, vertical heat transfer occurs between the upper and lower floors. There are 25 and 26 floors. 26 floor rotate 8 degrees from 25 floor, that is the maximum degrees of this building rotation. There is a non-overlapping space between the two floors. The non-overlapping space is directly connected to the outside and inside, and summer insulator is required to prevent heat transfer, that is, bulkhead. When lower floor is protruded more than upper floor, the outside air flows vertically into the inside. We need a summer insulator to prevent heat from entering the interior. In this situation, lower floor is exposed to the outside. The insulator is attached to ceiling inside and outside. Overall, you can find out that the insulator is attached to each ladder. Now, let's look at the structural issues of the cantilever structure. Summer break is needed to hold structure. When comparing simple beam and cantilever structure under the same load, 4 times as much moment are affected by the cantilever structure. Therefore, more reinforcement is needed. The summer break is not only one of the ways to improve summer efficiency, but it also serves as the additional load reinforcement in the cantilever structure, which needs more reinforcement. Next, I will explain the problems that occurred while implementing the high-rise building and how to solve them. The first problem is the high wind load. Looking at the equation of wind pressure, there is a problem that the wind pressure increases as the height of the building increases. The air velocity pressure increases. Therefore, high-rise buildings are greatly affected by wind pressure. To determine the effects of wind load, We need to know the mechanism through which the wind passes. As the wind passes through the building, a vortex flow is created. This vortex flow pushes building from side to side. Therefore, wind loss are more likely to cause resonance and cause the collapse of skyscrapers. The first way to solve this problem was to use a shear wall. Shear reinforcement was added to the load-bearing wall so that it could be used as a shear wall at the same time. When I apply the above-mentioned method of operating wind loss to our building, the red walls operate as shear walls resisting wind load in red direction, and the yellow walls operate as shear walls resisting wind loss in yellow direction. The overall operation looks like this. A second solution is to twist the building to distribute the wind load. When the building is twisted, it can be seen that the wind pressure is relatively low compared to other buildings. Twisted design is effective to dispersing wind loss. The second problem caused by high-rise building is stag effect. The stag effect is that when cold air suddenly blows into the lower part of the building in winter, warm air inside rises rapidly along the core of the building, negatively affecting the structural stability of the building. The stag effect causes three problems: structural instability of elevator, risk in case of fire, and difficulty to open and close doors. The first method to solve this problem is the air conditioning pressurization and decompression system. The main characteristic of this method is that the air is supplied and exhausted per unit cooling section. Because of this unit section, the pressure difference is decreased and so the stag effect is reduced. If the elevator shaft cooling is added to the general elevator shaft, the elevator shaft is cooled and consequently the stag effect is decreased. A third solution is to place a double statement. Placing a double door can reduce the occurrence of the stag effect since it is relatively easy to open the door and does not allow rapid cold air inflow. Although many problems were solved with the various methods reviewed previously, there were some that did not solve the problems. There are three things that were not solved from our project. First, it is a phenomenon that is mentioned as a problem with high-rise building. The building wind phenomenon is a phenomenon in which when the wind blows between skyscrapers, the wind suddenly passes through a narrow passage and the pressure is momentarily lower and the speed is increased, and the wind rotates at the back of the building. The second thing is, it is a light reflection phenomenon. that is emerging as a problem with the curtain wall method. Although the external of the absolute tower is not closed with curtain wall method, the glass on the balconies surrounding the front of the building reflect a lot of light. Problem with light reflection is that it reflects light directly on people or objects on the ground. It may disturb eyesight, and an accident can occur. So in general, film is used to solve light reflection. It is a principle of reducing light reflection by attaching a film to the window. In case of the absolute tower, light reflection was very high. It may not have counterplane. The last thing is building demolition problem. Absolute tower uses high-strength concrete such as PSG or SCC for a stable structure. Although it can develop high strength, there was a problem that it was very difficult to demolish the building later. There are references of this presentation. Thank you for watching. This is the end of our project.